Welcome to lesson 7-3 on different ways to solve a proportion. I'm going to be showing you 3 different ways today. Our goals, students will be able to find the missing part of 2 equal ratios or a proportion, to solve real-world problems and make predictions. So today we're just going to learn the how, and then the next day we will really be putting that into action with some word problems. So what do we know? We know that fractions are a ratio that compares a part to a whole. So everything we know about creating equivalent fractions also works for making 2 ratios equal to each other. So a picture to illustrate, the fraction 1/2 tells us that one part of our whole square is shaded. So here's your part that's shaded. Here's the whole number of pieces. Okay, over here, then the question is, so how many pieces out of 4 is equal to that 1:2 ratio? I could make this a for every statement and say, for every uh, one piece shaded, there are 2 pieces. So if we have 4 pieces, how many of those will be shaded? Now it has to equal 1/2. The ratio value of this, 1 divided by 2, would be 0.5, so the ratio value of this needs to also equal 0.5. So again, what part is shaded of the whole? Our whole now is 4 pieces. We can clearly see that 2 pieces are shaded. Another way to do that, I'm going to do times 2, and we get 2. So this is what we mean by solving a proportion. We set up 2 equal ratios that can look like fractions, and we find that missing piece. So here are some different ways to solve that problem. All right, so what I want you to think about as we talk about them, does one way always work for every problem the best, or should you know all 3 and then for each problem decide which strategy will work best in this problem? All right, so first we have an up and down relationship. Whatever I do from here to here, I do from here to here. So how do I get from 2 to 1? I would divide by 2. Then that's what I need to do here to get from 4 to x. I will also divide by 2. This works nice and easily. So 4 divided by 2, and I can see that x is equal to 2. We could also do a side-to-side relationship. How do I get from 10 to 20? I multiply that by 2. So I also have to multiply the top by 2, and then I would know that x is equal to 8. This is a strategy that we learned when we did our fraction chapter. Now, if you look at this third example, I can't get from 8 to 7 easily. It's going to be using a decimal, so that doesn't work extremely nicely. I also can't get from 8 to 20 nice and easily, so we need another plan. We're going to use what we call the crisscross. Now you remember cross multiplying to see if 2 fractions were equal. That was our airplane strategy. We learned that 8 times x, right here up in the cloud, this times this diagonally has to be equal to this times this up in this cloud. So we know that 8 times x, or 8x, is equal to 20 times 7, or 140, if we want these 2 fractions or ratios to be equal to each other. Well, I hope you recognize that we have an equation that we can now solve. So our equation, I'm going to rewrite down here, is 140 is equal to 8x. The opposite of x times 8 is to divide by 8. We have to keep the balance and divide this side by 8. So x is left here. Use your calculator to do 140 divided by 8, and that equals 17.5. So x is going to be 17.5. So these are your 3 strategies. Look for an up and down relationship that works nicely. If you don't see that, try a side-to-side relationship, multiplicative relationship that works nicely. If you get to a problem where neither of those strategies works well, then try the crisscross. This times this equals this times this. Then you simply solve your equation for x. All right? I want us to look at these three problems. We're going to decide which of these three strategies we think is going to work the easiest, and we will circle that and then go ahead and solve. Here's our first, 8 over x equals 7 over 28. First all you will look, I'm going to look side to side first. Can I get from 7 to 8 nice and neatly? And I'm going to say no. 7 times 1 is 7, 7 times 2 is 14. So that is not my easiest strategy. Let's look for that up and down. I can see that, yep, 7 times 4 is 28. That works really nicely. So 8 times 4 is going to equal x. X is going to be equal to 32. So our up and down relationship was the best strategy for that problem. Let's try number 2. Let's try that up and down, 20 to 15. Notice that my arrow goes in whatever direction would be towards the x. Sometimes that's down, sometimes that's up. Is there a nice and neat way for me to get from 20 to 15 without a decimal? No. So that's not going to be my best strategy for this problem. How about side to side? We always want to go towards x, our arrows. So 20 to get to 4, that does work nicely. I will divide by 5. So we have to divide the top by 5. So x is going to be equal to 3. So that did not work for us, but this worked very nicely. All right, this last problem, let's try our up and down. Always want to do your arrows towards the x. Is there a nice, easy way to get from 4 to 5 without a decimal? No. So we'll cross that out. That's not going to be the best strategy. How about side to side? Go towards your x. And 4 to 10, that's going to need a decimal, so that doesn't work very well either. So let's try our crisscross. Go ahead and do your cross products. 5 times 10, put your answer in the cloud, that's 50. If I want my ratios equal, I need my clouds equal. So x times 4 is 4x. Now we have an equation. Let's rewrite that so I have room to solve. 4x equals 50. We know how to solve that. The opposite of x times 4 is to divide by 4. Keep the balance and divide the other side by 4 also. Over here we get x is equal to 50 divided by 4. You may use a calculator for that. And you will get an answer of 12.5. It is okay to have a decimal as an answer. Okay, so in this situation, our crisscross was the best way to go. All right, now I want to show you, if you're having trouble with the crisscross, I want to show you one other solution for the ones that don't work out so nice. So here are our two examples that we've already seen that we used the crisscross for. I want to show you one other way that you may always use if you prefer this. Now, we can still use the side to side and just use our calculator for a little bit of help. Here's what we do. We're going to ask ourselves, how do we get from 4 to 10? 4 times something is going to equal 10. Well, let's go backwards. We know fact families. You did this in elementary school. That 4, whoops, how about 4 times 5, for example, 4 times 5 is 20. So these multiply to get this, but then this divided by this is going to equal this. So let's go backwards. 10 divided by 4, if I do that on my calculator, I get 2.5. So this divided by this is going to tell me what this something is. So 4 times 2.5 equals 10. Again, I just went backwards. I said 10. If 4 times something is 10, then 10 divided by 4 tells me that's something. Well, now I know that it's times 2.5, so I'm going to multiply the bottom by 2.5. Again, I'm going to use my calculator. 5 times 2.5 is 12.5. So that is another way you can solve. That takes away from that crisscross and solving an equation. That works very nicely. Let's try that over here. Let's say I don't want to do crisscross. My arrows go toward the x. I know that 8 times something equals 20. So 20 divided by 8 equals something, according to fact families. So on my calculator, I'm going to do 20 divided by 8. And again, actually, it equals 2.5. If I multiply the bottom by 2.5 to get 20, then I also am going to multiply the top by 2.5 as well. And 7 times 2.5 is going to equal 17.5. Please rewatch this if you need a review on these strategies, and good luck.